All right, here we start with question practice 5. Rewrite each of the following reactions as net ionic reactions. Make sure you have your strong acids and bases memorized. And know your ionic salts should be completely ionized. So this guy right here is a nitrate salt, so let's split it up. So then it becomes Fe posi 2 and 2 NO3 minuses. How do I know that it should be split up? Well, remember that all nitrates are soluble. And don't forget the little charges in the upper right-hand corner. And then this is a strong base, so it splits up, and don't forget to distribute the 2, so it goes into both places. And then iron hydroxide, remember all hydroxides are insoluble except for elements from group 1 and then the strong bases and ammonia. And iron is not in that area, so that is a solid, and it has a little S right below it. That means that it is a precipitate. And then we're going to end up with 2K plus and 2 NO3 minuses over here. To make the net ionic equation, the potassiums would cancel, and then the nitrates would cancel, and then my underlined species right here would be my net ionic equation. Next one, we've got some ammonia, which is a molecular substance that dissolves in water. We leave that together. And then HClO is a strong acid, so we split that up into H plus and ClO3 minus. And then over here on the right-hand side, all ammonia salts are soluble, so NH4 plus and ClO3 minus split up. If you forgot that all ammonia salts are soluble, look right here. Here it says ammonias. And then it doesn't look like anything really cancels on this except for the chlorates. So then we just have ammonia gaining a proton to become NH4 plus, which is what bases do. Then let's see, in this one right here we have nickel bromide, which is soluble, so it becomes Ni plus 2 and 2 Br minuses. You know it's soluble for 2 reasons. First of all, it says aqueous right here, and then of course all bromides are soluble except for silver, mercury, and lead. And then barium is a solid right here, so you got to leave that together. And then over here nickel is a solid, so you have to leave that. And then barium bromide, of course, is soluble because all bromides are soluble except for silver, mercury, and lead. And then the bromides cancel, and then we're left with the redox reaction of nickel plus 2 being reduced to nickel, and then barium going to barium plus 2 and being oxidized. Write the complete net ionic equation for the next 2 reactions. So a solution of concentrated hydrochloric acid reacts with aqueous base ammonium. I think that's supposed to just be ammonia. Yeah, ammonia, to form ammonium chloride, so that's correct. So then this becomes the NH4, and it gains the Cl right here to become ammonium chloride solution. So aqueous solution right here, and this is aqueous 2. This is ammonia, which is a weak base, and then this is aqueous because it says it's a concentrated hydrochloric acid solution of. And so then this is a strong acid, so split it up into H plus and Cl minus. First, make sure the equation is balanced, and it already is. And then it's plus NH3. And then this splits up because it's a soluble ionic salt, NH4 plus and Cl minus. The Cl minuses cancel, and look at that. We get a similar reaction to what we had up there. Letter B, a solution of the strong base barium hydroxide reacts with acetic acid, and acetic acid is HC2H3O2. And then that produces barium acetate, so barium and then acetate is C2H3O2, and there's a 2 right there because barium's plus 2 and acetate is minus 1, and then it forms from water HOH. To balance this, we're going to need a 2 right here, and I believe we need a 2 in front of the water. Now, since we have the balanced reaction right here, we're going to have to split it up. Barium hydroxide, of course, splits because it's a strong base, so that becomes barium plus 2 and 2 OH minuses. Acetic acid stays together because it's a weak acid. It's not a hyperhickel high, homohickel OH2SO4. And then this guy over here splits because all acetates are soluble. If you forgot that, it says right here all acetates are soluble. And there's 2 C2H3O2 minuses. Notice how the 2 came out front here, and you still have the charge. And then water, of course, is molecular, so that sticks together as well. There's our complete ionic. To get the net ionic, I believe we'd have the bariums cancel, and the remainder would be the net ionic equation. That is question 5. Here's question 6. Lots more reaction writing. At the balance in the full molecular, not ionic form, representing the ones before. So we're just doing the full molecular now, so all we have to do is write it and balance it. C2H6 is going to react with combust, so it's going to react with oxygen, and then it's going to form carbon dioxide, and then it's going to form HOH in its gaseous state. we can omit the solid liquids and gases right now. We're just going to work on balancing it. When you balance these that are hydrocarbon combustions, balance them alphabetically. Carbons first, then hydrogens, and then oxygens. So the alphabet goes in that order, so balance them in that order. So if you put a 2 here for the carbon, then a 3 here for the hydrogen, you're pretty close because you have 2 carbons and 2 carbons and 6 hydrogens and 6 hydrogens, but your oxygens are mixed up because 2 times 2 is 4 plus 3 is 7, so this would have to be 3.5. So really to balance the thing, what you'd have to do is double the whole reaction, so multiply it all by 2. So distribute a 2 in, so you'd end up with 2. This would now be 7. This would now be 4. And this would now be 2 times 3, or 6. So there's your balanced reaction. Notice how I balanced them alphabetically. You use that again in butane right here. Butane C4H10. If you forgot that, you can look up your prefixes right here. But, remember, means 4. And remember, it always fits the formula C to the X, H to the 2X plus 2. So that's why it's 10. And then it reacts with oxygen because it's going to combust, and then it's going to make carbon dioxide once again and HOH. So similar balancing to before, so you need a 4 right here for carbon, and then you need a 5 right here for hydrogen, but you'd find out your oxygens are messed up because 4 times 2 is 8, plus 5 is 13, so you'd actually need 6.5 right here to get the correct number of oxygens. But since you can't have halves there, double everything. You get a 2 here. I think you end up with a 13 right here, and then this becomes 8, and this becomes 10. The following reaction is complete and balanced. Magnesium carbonate is insoluble. So swap the cations. Na goes together with Cl, so you get some NaCl, and then put the cation first. Magnesium goes with the carbonate, so we end up with MgCO3. And then there's a 2 right here for sodium, and that's a 2 right there with chloride, and then you have the balanced molecular equation. Letter B, silver nitrate, AgNO3 reacts with aluminum sulfate. Remember, aluminum is positive 3. If you forgot that, you can look on the periodic table right here, and you know aluminum's in group 13, and you should have a little plus 3 written right there. Sulfate is the polyatomic ion SO4 and is minus 2, so you need a 2 here and a 3 here. Arrow, silver swaps with the aluminum, so you're going to end up with the aluminum together with the nitrate, so AlNO3, and then you get the silver together with the sulfate. Silver is always positive 1. I think it tells you that right here, but you should have positive 1 written above the silver right here, and you should always know that. And so you're going to have Ag2SO4 over here. Now, it's not quite balanced yet, I think. Let's see, let's trick this out here. This is going to have a 2, a 2. If I start with a 2 right here, it goofs it up because I actually need more of that. So let's double this. That gives me 6 of those. So give me 6 of these nitrates right here. Then I'll need a 3 here for the silver, and that gives me 3 sulfates, which I have right there, and it's balanced. Following reaction is complete and balanced. Iron 2 ion right here is reduced and cadmium is oxidized. So that's telling me that iron right here is going to go down to be just basic iron, 0. And then cadmium right here is going to replace the iron, and it's going to form with the chlorine right here. And if you forgot, cadmium is always a positive 2 ion, just like zinc right here. So those 4 elements right there you should just always have memorized. Since this is plus 2 and chlorine's minus 1, you end up with CdCl2. Balanced. Solid nickel is oxidized to its plus 2 state by zinc nitrate solution. So zinc nitrate solution would be ZnNO3 Remember that zinc is always positive 2. It's written right here on your periodic table. If you don't have it written down there, please write it right now. And then solid nickel is oxidized, so solid nickel is just Ni. So Ni and zinc are going to swap places, so you end up with NiNO3 over here, and it says it's oxidized to its plus 2 state, nitrate's minus 1, so you're going to need a 2 right there to make sure that that's balanced, and then zinc is all alone by itself to its 0 oxidation state. Next, the acid-base reaction between hydrobromic acid. Hydrobromic is a strong acid with barium hydroxide, Ba, and then be careful because barium's positive 2. Don't forget barium's plus 2 right here. So you need 2 of them right here, and don't forget parentheses. Swap the cations, you end up with HOH together, and then the barium is the cation, so that goes together with the bromine. Don't forget the 2 right here, because remember barium's plus 2 and bromine's minus 1. We need a 2 right here to balance it. I think we're good. D number 2, the acid-base reaction between hydrochloric acid and strontium hydroxide, SrOH2. Don't forget that strontium is positive 2. So then you need a 2 down here, and don't forget the parentheses. Swap the cations, we end up with H swapping with strontium, and then strontium goes together with the chlorine, and you end up with SrCl2. 2 goes there in front of the water to balance the reaction. The reaction of lithium carbonate, lithium 2 carbonate, right here, with hydrochloric acid. Hydrochloric acid is HCl. So now lithium goes together with the chlorine, so you get LiCl. And then we get some H going with the carbonate. Now this is a weird one because remember all carbonates when they react with water they end up making the carbonic acid H2CO3, but this immediately decomposes and so then it becomes water and a gas, CO2 gas. So technically that's the way you're supposed to write it. So watch out for your carbonates, watch out for your sulfites, watch out for your hydrogen carbonates, because when those react with acids, they always form a gas. I think this one's not quite balanced yet. I think I need a 2 here and a 2 here to make it balanced. Alright, let's see, the reaction of aqueous sodium sulfite. So watch out for this one, because sulfites, when they react with acid, doesn't matter what acid, in this case it's hydrochloric acid, they're going to form a gas. So swap the cations again, you're going to get some NaCl, NaCl. And then you're going to end up with some H2SO3, which remember completely decomposes right away, and that gives us water and some sulfur dioxide gas. I think we need a 2 here in front of the NaCl to balance it. And maybe a 2 right here, yeah, to give us the 2 chlorines. Alright, now this one, NaHCl3, watch out for this one as well. This is another one that when it reacts with acid, it's going to form a gas-forming reaction. So you're going to get some NaCl over here, and then you're going to get some H2CO3, which we indicated up here, automatically decomposes, and then we get water, and we get some carbon dioxide gas. To balance this one, I believe we need a 2 right here. Nope, maybe not. Don't need any numbers to balance that one. I think that one's already balanced, so good to go. Watch your gas-forming reactions. Best of luck with your reaction problems. More in the next video.